Alright, so today we are going to recap about sketching of exponential, and we are going to learn how to sketch logarithmic graph. So 2 parts here. Okay, by right, you just need to memorize, but in case you, during exam, you are a bit panicky, you cannot remember, can we try this? You sub in 3 values, okay? For example, one will be the negative, one will be 0, and one will be a positive. So what does it mean by here? It means that I want y equals to e power negative 1, e power 0, and e power 1. What will the answer be? 0.36 something, right? E power 0, press e power negative 1 is 0.36 something. I just put 0.4 lah. I just need a rough idea what is the value. This is 1, and then this is 2.7, right? Okay, so when it's negative 1, I will have quite a small number. When it's 0, I will have 1. When it's 1, I will have 2.7. So how does the graph look like?
Not linear.
Yeah, it's not linear, so please just memorize that the graph will look like this. All right? And the value here will be 1. That's all. Now, in case, again, you forget, right? During exam, you're a bit freak out. So y equals to e power negative 1, e power negative 0, and e power negative 1. So what will happen? They will just be the opposite, right? 2.7 first, then 1, then 0.4. So I will have 2.7 first, 1, and then 0.4. So what will happen? You flip okay, about the y-axis. Y equals to negative e to the power of negative 1, negative e to the power of 0, negative e to the power of 1. What's the value? Negative 0.4, negative 1, negative 2.7. So it's getting more and more negative. As I move to the right, it's getting more and more negative. So do you all know how it looks like? So as long as you can recall the general shape, you should be able to sketch. Okay, so in case just this question alone come out, you press negative e to the power of negative 1, negative e to the power of negative 0, negative e to the power of negative 1. Okay, yeah. I'll have negative 2.7, negative 1. This one will be this, the same, negative 0.4. And so you will get less and less negative. So this one, when it's negative 1, I'll have negative 2.7, negative 2.7. Then I'll have this. Then I have negative 0.4.
Is the exact quantity important, or we just need
No, you just need to roughly sketch. But having said all this, can we please write down the y-intercept?
So the usually we only need to write y-intercept, and the exact coordinate doesn't matter.
Yeah, the exact coordinate doesn't matter. And one more thing, everyone look here. When this number change to a number 2, how would the graph look like?
Same.
It looks exactly the same.
The same or different scales.
Only the scale, okay, we assume the scale has changed, but it will look exactly the same. Okay, it doesn't matter what number this changed to. It can be number 5, it can be a 10. Doesn't matter what number it changed to, it will look exactly the same. Exactly the same. All right, now today we are going to use the same set of skills to do logarithmic graph. So why we never choose negative 1 and 0 as the substitution points? It will be undefined. Log 0 undefined, log negative 1 also undefined. So we choose some positive number. But you must recall, please, you must choose a number that is a decimal. Okay, so just recall this, just remember this. Okay. Now press calculator, your y value will be, sorry, negative 0.3. Log 1 is 0. Okay, I just keep everything constant. So log 2 is 0. Correct. Okay. Negative 0.3. When it's 1, I have 0. When it's 2, I have 0.3. So how does it look like? You may think it's like that, huh? Cannot, huh? It is this way, huh? Why? How do I remember that it's this way? The graph cannot cut 0, cannot cut negative.
Remember there's an asymptote at the y.
Yeah, this is the y-axis is called your asymptote. That means it will never touch it one. The graph will approach it, but it will never touch it. Press ln. Okay, so your y will be ln 0.5, ln 1, and ln 2. So what's the answer? Negative 0.7. Ln 1 is 0. Ln 2 is 0.7. Okay, so I will have negative. I will have 0. I will have positive. But you cannot cut this. You cannot cut the y-axis. Cannot cut the asymptote. So you got to only cut this way. What is this number here? It will always be 1. Okay, now lastly, this is interesting, everyone. This one. So you got to press log 1/3 0.5. So how do you press this? You can press LG 0.5 over LG 1/3.
Yes.
Just finish first. 0.6. So press LOG 1/3 1. Answer is 0. Press LOG 1/3 2. Press LG 2 over LG 1/3. Negative 0.6. Now things has changed. When it's 0.5, it will be 0.6. When it's 1, it will be a 0. When it's 2, it will be a negative here. How does it look like? So again, y-axis is your asymptote. So you cannot touch it. Alright. Okay, now this is the last part of the chapter. We are going to learn how to apply exponential and logarithmic functions, alright, into the problems like this. Now, a cup of coffee, this is example 5 of page 109 of your resource book. A cup of coffee was left to cool down so that t minutes later, the temperature is given by this function here. Now, you realize that this function has the exponential function inside. So this is just an example. Later, your homework, you do the logarithmic one and some exponential ones. Now, I changed the question a bit. I included this. Find the highest temperature. So when do we have the highest temperature? When? At what? Yes. So I purposely include this because it's very common that the first part actually asks you to find something when t is 0. The initial part, the beginning part. So at the beginning part, whereby t minutes later, there's no time has passed, so it's still very hot. Then I will find the value of t, which is simply 27 plus 58 multiplied by 1. Why? Because this is power 0, right? So this is just 1. Yeah, so the answer is 85 degrees Celsius. That's all, very simple. Find the temperature 5 minutes later. So what is 5 minutes later? You look at here. Alright, so 5 minutes later, I will have t equals to 5. Now, this is a small t. So please identify what variable this is. So I have t equals to 27 plus 58 to the power of 5. Okay, and the answer is 65.2 degrees Celsius. So very easy, right? Okay, part C. Now, what is 50? What variable is that? It is the capital T, which is your temperature. So 50 equals to 27 plus 58. So the objective of this question is for you to solve for T. How do I solve for T? I minus away 27 first. That will give me 23. I minus 27. I divided by 58. And I'll be left with 0.92 to the power of t, right? This is the part that's important. How do I solve? Yes, correct. This is an exponential form, right? You just change to a logarithmic form. to solve this. So I will have log base 0.92 23 over 58 equals to t. Log this over log 0.292, log 23 over 58 over log 0.92.
Is 11.09.
Answer will be 11.1 minutes. Okay, the last part. Show that t equals to this, which means I want to make t the subject. So starting with here. Okay, let's go through this one last time. Okay, follow the steps. First step. Okay, then I divide both sides by 58.
Okay, you get the equation minus 27 both sides and divide by 58 on both sides. So 50 minus 27.
Again, in order to change to this, I will change to logarithmic form. Log base 0.92, and then on the other side, and equals to t. All right. Okay, can we stop?